This is 3.5 pre-calculus day 2 homework. We are doing composition of functions and different operations, adding, subtracting, multiplying, and dividing functions, and talking about the domain. So for this first one, they're asking you to do 3 things. Add f and g of x, and then subtract f minus g, and then g minus f. Well, if you added these two, it doesn't matter what order you add them, and this is x to the third. And negative 3x plus 2. So if you added these two functions, f plus g of x will give you, if you added these two, you get in order x cubed minus 3x plus 2. But now if you're going to subtract, order matters. So if you're doing f minus g, you're going to take negative 3x plus 2 and subtract x cubed. You end up with negative x cubed minus 3x plus 2. You have to distribute the negative. Now g minus f is going to give you x cubed minus, we have negative 3x plus 2. So we have to distribute the negative, so it's x cubed plus 3x minus 2. And that's in order. For number 3, again, they want you to add the two functions. If you added them, f plus g of x. If you added these two, you simply get x squared plus 2x minus 5, and then plus 1 over x. If you do f minus g, this minus this, you're going to get 1 over x. And I can just do minus, I'm going to distribute the negative, x squared minus 2x plus 5. And the other way, g minus f of x is going to give us x squared plus 2x minus 5 minus 1 over x. Number 5, we want the product and the quotient of these. So f times g would be negative 3x plus 2 times x, and that would be x cubed. So if you distribute, you get negative 3x to the 4th power plus 2x cubed. Now if I do f over g, so this is the answer to the first one. This is f times g. F over g is going to give us negative 3x plus 2 over x cubed, and there's nothing you can do there. And now the domain is all real numbers except x can't be 0. And g over f of x is going to give us x cubed over negative 3x plus 2. And x cannot be 2/3. For number 7, they want you to multiply these two. So f times g is going to be x squared minus 3 times the square root of x minus 3. You can just leave it like that. And now for this, the domain is going to be x is greater than or equal to 3, because you can't have anything less than 3 for this one. The quotient of f over g is going to be x squared minus 3 over root x minus 3. And for this one, the domain is going to be x is greater than or equal to 3. Actually, you can't have 3 because you can't have 0. So the domain on this one is going to be from 3 to infinity. You cannot have a 3 here because 3 minus 3 is 0, and 0 in the denominator does not work. And then the other way, g over f is going to give us root x minus 3 over x squared minus 3. And for this one, the domain has to be, you can't use, for the top, the domain is 3 to infinity, but the bottom, x is equal to plus or minus root 3. It can't be. So the intersection of these two is your domain. So it can't be -3. If you look at both of these in the numerator, your domain is all numbers from 3 to infinity. And then for the bottom, x can't be 1.7 or -1.7. Well, both of those numbers are before the 3. So this is what your domain is going to be. It's going to be from 3 to infinity. Because these two numbers are not in this region, and it has to be the intersection of both of those. The next one. For number 9, they want the product of f times g. So it's x squared plus 1 times 1 over x. And then f over g would be x squared plus 1 over 1 over x. For number 10, the product would be x plus 2 times 1 over x plus 2. And the quotient would be x plus 2 over 1 over x plus 2. And you can, if you flipped and multiplied this, you would end up with x plus 2 quantity squared. And we're going to skip 12, it's hard to read. I can't make out those exponents. We're just going to move on. 13 through 16, these are compositions. You're going to plug the input into f here. You're going to plug 3 in the f function. If you were to plug 3 in the f function, you have 3 times 3, and then you're going to subtract 2. So 9 minus 2 is 7. Then you're going to plug 7, the output of the input of when x is 3 in the f function, you're going to put, that's now going to become the input in the g function. So you're going to find g of 7. So 7 squared is 49. So that's the first one. For the second one, they want you to plug 1 into g. So if you put 1 in here, 1 squared is 1. And then that answer goes in here. So 3 times 1 is 3, and 3 minus 2 is 1. Okay, so for this one, if you did f of g of 1, you're going to plug 1 into the g function. So that'll give you a 1. And then you plug 1 in here. 3 times 1 is 3. 3 minus 2 is 1. And then the last one, they want you to plug 0 in the f function and then the result again in the f function. So if you put 0 in here, 0 times 3 is 0. 0 minus 2 is -2. And then you're going to plug -2 into the f function. So 3 times -2 is -6 minus 2 gives us -8. Number 14. If you plugged 3 into the f function, if I plug 3 right here, 3 plus 2 is 5, the absolute value of 5 is 5. And then 5 goes into the g function, so you have 5 squared is 25, 25 times -1 is -25. So that's the first answer. Then f of g of 1, if you plug 1 into the g function, you get 1 squared times -1 is -1, and then -1 in here, -1 plus 2 is 1, absolute value of 1 is 1. And the last one, 0 in the f function, 0 in here you get 2, absolute value of 2 is 2, and then 2 into the f function, 2 plus 2 is 4, absolute value of 4 is 4. And for 15. 15 says f of x is equal to x. And g of x, there is no x value, but it's x, 0x minus 3. So think of it that way. So if you did g of f of 3, g of f of 3. If I plug 3 in here, I get a 3. And if I plug 3 in here, I get -3. then f of g of 1. If I plug 1 in the g function, I get negative 3. Then negative 3 into the f function, I get negative 3. And then f of 0. If I plug 0 in here, I get 0. 0 back in there, I get 0. Backside. Okay, 17. You're going to find f of 0. You're going to plug 0 in the f function, and then plug that answer in the g function, and add 0 into the g function, and that result into the f function. That's our game plan. So when we plug 0 in the f function, put a 0 here. 1 plus 0 is 1. So then what's g of 1? If I plugged 1 in here, 1 squared is 1, and 1 minus 1 is 0. So this gives us a 0. And then if I plug 0 in the g function, I get 0 squared minus 0. And then 0 back in here, I get 1. So 0 plus 1 is 1. Next one. This one's asking us to plug 3 in the g function. If I plug 3 in this g function, I get 3 squared, which is 9. 9 minus 3 is 6. So I need to find f of 6. If I plug 6 in here, 6 plus 1 is 7. Minus 2 times f of 1. When I plug 1 in the f function, 1 plus 1 is 2. Well, 2 times 2, I'm just going to put a 4 right here. And 7 minus 4, the answer is 3. And f of 2, if you plug 2 in this function, 2 plus 1 is 3. G of 3, I'm sorry, this one is written different. This is saying g of f, you gotta watch those parentheses. So what they want you to do is plug 2 in the f function. We were doing that right. 2 in the f function, 2 plus 1 is 3. Then they want you to add 3 to that number, which is 6, and then find g of 6. So if I put a 6 here, 6 squared is 36. 36 minus 6 is 30. Okay, 21 and 23 want you to find the rule for f of g and g of f. So what that means, and then they want you to find the domain. Well, the domain is the intersection of both of these, and both of these are all real numbers, so the domain on both of them is going to be all real numbers. But to find g of f, that means you plug this in here. So g of f of x is x plus 3 quantity squared. And you can simplify that to x squared plus 6x plus 9. And again, the domain, all real numbers. Now f of g of x, that's saying take the g function. I'm sorry, I did this. This one is the f. This is f. F of g should be, my bad. This one was f of g of x. So this one, you're going to plug this in here. You should have gotten x squared plus 3. X squared plus 3. And then f of g of x, you're going to plug this in here, which is the answer I just had. X plus 3 quantity squared, and that's when you'll FOIL this. So g of f of x, you plug the f function into the g function, and you get x squared plus 3. F of g of x, you plug the g function into the f function, you're going to square it, and you get x squared plus 6x plus 9. Moving along. Let's talk, before we do the composition, let's talk about the domain of this. The domain of this is x cannot be 0, all real numbers. For this one, the domain is 0 It can't be 0. Well, it can be 0, 0, square root of 0, 0, 0 to infinity. So you're going to look for where these two intersect. So the intersection, since it can't be 0, the domain is going to be from 0 to infinity. That's what the domain is of the composition. So now, to find f of g of x, this is saying take the g function and plug it into the f function. So you have 1 over square root of x. And then g of f of x, you're going to plug this in here. So you have root. So this goes in here. So you have 1 over x. Square root of 1 over x. Okay, the next one, 25. There's two things they want you to do, ff and f of f. Well, what I would do is I would rewrite this again. So I can see, what is ff? It means take these two and multiply them together. So what's x squared times x squared? It's simply x to the 4th power. If bases are the same, you add the exponents. Well, what's f of x? You're going to take this and plug it in here. So you have x squared squared, and it results in x to the 4th power. Same with 27. They want f of x, and they want ff of x. So what I would do is I would rewrite this again. So f times f is going to be 1 over x times 1 over x, which is 1 over x squared. Well, f of x is going to be, you're going to plug this in here. So you have 1 over x. And if you flip and multiply, this results in x. '29, you have a composition of functions here. What they want you to do is prove that f of g of x and g of f of x both result in x. So you may need a separate sheet of paper to do this one. So what is f of g of x? It better be x. So you're going to plug this in here. So 9 times x minus 2 over 9, and then plus 2. Well, we're going to simplify these. These cancel, and you have x minus 2 plus 2. The 2's cancel, and you have x. So that one works. Now, what would g of f of x be? You're going to plug this f of x in here. So you have 9x plus 2, that's what this is, minus 2 all over 9. Well, these cancel. 2 minus 2 is 0. The 9's cancel, and you end up with just x. So what that means is these two were verifying that these are inverses of each other. And we just did it. There it is right there. You have to do the composition both ways, f of g of x and g of f of x. Okay? Same with 31. You're going to do f of g of x and g of f of x. So if you were to plug this in here, you have the cube root of x minus 2 cubed plus 2. Well, you have the cube root of 3 of these, so you end up with x minus 2 plus 2, which is just x. Okay? And when you do the other one, when you plug this, you're going to plug this now in here, you have g of f of x. If you plug all of this in place of this x, you get the cube root of x plus 2, and then minus 2, but you have this all cubed. Well, these two cancel out. You have the cube root of x cubed, which is just x. 33, 35, and 37, you're going to split these functions. So if f of x is the cube root of x squared plus 2. I'm going to rewrite two new functions. Let's use g of x and h of x. I'm going to call g of x what's underneath here, x squared plus 2. And h of x is going to be the cube root of x. So f of x is consisting of g of h of x. So let's see if this makes sense. If I plug this into here, does that work? No. So I need the h to go outside and the g to go inside. So now, does that make sense? If I take this and plug it in here, do I get f of x? And you sure do. So for 35, I think this is 7x cubed minus 10x plus 17. We're going to go with this to the 7th power. We're going to split this. So we're going to call f of x is going to be something to the 7th power, x to the 7th power. And g of x is going to be the guts inside here, 7x cubed minus 10x plus 17. So h of x is going to be, now we want to put this into that. So that's going to be the outside. So f of x, f of g of x. Let's see if this works. If I took this and stuck it in here, I get h of x, and it works. And the last one on this page, we've got f of x. So let's name g of x is 1 over something. And h of x is 3x squared plus 5x minus 7. So f of x equals g of h of x. So if you plug h of x in here, you get this f of x. And the last one, which is actually very easy, 41 through 44. You are given two charts, an f of x chart and a g of x chart. This is the input, this is the output. Input, output of g of x. This is f of x, this is g of x. So for this one right here, you have to fill out this chart. So you're going to put a 1 in. It's asking you for g of f of x. So you're going to plug 1 into the f function. If you plug 1 into the f function, you get a 3. And then you're going to plug that 3 into the g function, and you get 4. So now we're going to try 2, 3, 4, and 5. So if you plug 2 into the f function, you get a 5. 5 into the g function, you get a 2. 3 into the f function, you get a 1. 1 into the g function, you get it's a 5. Yep. 4 into the f function, you get a 2. 2 into the g function, you get a 4. And 5 into the f function, you get a 3. 3 into the g function, you get a 4. We're going to move down to 43. This is saying f of x, and the numbers are 1, 2, 3, 4, 5. So we're going to plug 1 into the f function, and then the result goes back into the f function. So if you plug 1 into the f function, you get a 3, and then 3 into the f function, you get a 1. 2 into f, you get a 5, and then 5, you get a 3. 3 into f, you get a 1, 1, you get a 3. 4, you get a 2, 2, you get a 5. And 5, 3, 3, 1. Okay, for 42, problem? So, for this one, you want f of g of x. So if you plug 1 into the g function, you get a 5, and then 5 into the f function, you get a 3. 2 goes into g, you get a 4. 4 into f, you get a 2. 3 into the g function, 3, you get a 4. 4 into f, you get a 2. 4 into g, you get a 3. 3, you get a 1. And 5 into g, you get a 2. 2 into f, you get a 5. And the last one, g of g. So we just want to concentrate on the g column. So if you plug 1 into g, you get a 5, and then 5 into g, you get a 2. So 2 into g, you get a 4. 4, you get a 3. 3, you get a 4, and then 4, you get a 3. 4, you get a 3, and 3, you get a 4, and that was done. And 5 into the g function, you get a 2. 2, you get a 4. And that concludes 3.5 Day 2 homework.